So for today, what we will see is equivalence relation. Equivalence relation. So let's see. Let's suppose we have some set given A, okay, and on this set A, there will be a relation. There will be a relation that is going to be reflexive, symmetric, and transitive at the same time. So, if there is any relation on any set A that follow reflexive, symmetric, and transitive, the three of these relations, then that relation is called as equivalence relation. Equivalence relation. Okay. Let's understand it with the help of an example. So let's take an example. Suppose we have a set A whose value is 1, 2, and 3. So let's make the relations. Our first relation is empty relation like this, 5 value. So is it reflexive? If you have already studied reflexive relation, you have studied that if there is 1, then there should be 1, 1, 2, 2, and 3, 3. But in this one, there is no 1, 1, no 2, 2, and no 3, 3. So this relation is not reflexive relation. And if one of these three condition is not satisfied, then of course we can say that this relation is not equivalent relation, equivalence relation. So this can be proved very easily. Now we will see second R2 relation. Here the relation contain 1, 1, 2, 2, and 3, 3. Okay. So is it reflexive? Yes, it is reflexive. It is reflexive because there are three elements in this, 1, 2, and 3. And for every element, the diagonal elements with it are present, like 1, 1, 2, 2, and 3, 3. So yes, this is reflexive. Now we will check symmetric. For symmetric, we can say that if there is AB, then there should be BA also. So if there is 1, 1, then there should be 1, 1 also. So it already satisfy all the thing. Let's suppose that if we have 1, 2 in this relation, then there should be 2, 1. But there is nothing like this in this relation. So we can say that it is also symmetric. For transitive we say that if there is AB and BC, then there should be AC also in that relation. But there is nothing such thing in this relation, so that's why it is also transitive. So together we can say that it is an equivalence relation. And one thing you have to observe here is the very smallest relation that we can make on this set A is this one, this relation R2. So I should write here, this is the smallest equivalence relation. Smallest equivalence relation. Okay. Now let's see the next example, R3. We will write here 1, 1, sorry, it's 1, 1, 2, 2, 3, 3, and let's suppose I write here 1, 2. Okay. So now see, this is reflexive. Yes, this is reflexive. So it is satisfying the criteria of reflexive because there is 1 1 2 2 and 3 3 present. Let's check for the symmetry. So is it symmetric? For symmetric, if I have 1 2 here in the relation, then there should be 2 1 also in this relation, but there is no 2 1 in this relation. So this is not satisfying the symmetric. So if it is not satisfying the symmetric, we don't need to check the transitive now because 1 is already unsatisfied. So we can say that it is not equivalence relation. Okay. So now let's check the next one, relation 4. Let's suppose we will write here 1 1 2 2 3 3, and I'll write here like 1 2 and 2 1. So let's see this. Is it reflexive? Yes, it contains all these values, so it is reflexive. It is symmetric. So yes, it is also symmetric because there is 1 2 and 2 1 also present, so this is symmetric. And let's check for transitive. So for transitive, it is also transitive because if there is 1 2 and 2 1, then 1 1 is also present here. So that's why it is also transitive. So this relation is also equivalence. Okay. Now let's see the next relation. So the example is 1 1 1 3 2 1 3 1. Okay, so this is our relation. So let's check it. Is it reflexive? For reflexive we should have 1 1 2 2 and 3 3. So there is 1 1 and there is no 2 2 and there is no 3 3. So this is not reflexive, and now we don't need to check the symmetric and transitive. We can say from watching this one that it is not equivalence. So this is the example. Now let's see our next example, that is relation R5. So we can write here 1 1 2 2 3 3 and 1 2 1 3 2 1 and 3 1. So you need to tell me that it is equivalence relation or not. So let's check it together. For reflexive, we should have 1 1 2 2 and 3 3 because the relation was on set A and whose element was 1 2 and 3. So yes, we have 1 1, we have 2 2 and we have 3 3. So yes, it is reflexive. Let's check the symmetry. So for symmetry, if I have 1 2, then there should be 2 1. Yes, it is present. If I have 1 3, then there should be 3 1 present. Yes, it is present. So this is also symmetric. Let's check for transitive. So if I have 2 2, then there is 2 1. So 2 and 2 is similar here. For transitive, we have already seen that if there is AB and BC present in the relation, then AC should also be present. So is there something like this pattern, AB and BC? So there is nothing like this. But let's see this one. Like here is 2 and here is also 2. So 2 1 is present. Yes, 2 1 is also present. It is 1 3 and 3 1 like this. Let's see. 3 1 and 1 3. So 1 1 is common here. So is 3 3 present? Yes, 3 3 is present here. So this is also transitive. So from together these three, we can say that the relation here is also equivalence. Now let's see the next relation, that is R6. So the relation contain 1 1, 1 2, 2 1, 2 3, 3 1, 3 2, and 3 3. So this is our relation. First, we always what the process we were following, we will follow that.